Suppose there are 10 metal balls, let's say, and you know that one of them is heavier. Now, what is the minimum number of weighings to find the heavier ball? So we need to weigh different groups of balls and sort of narrow down where is the heaviest in the minimum amount of weighings. Now, ordinarily, right, you would have 10 balls, and most people would just split it in half, right? So groups of 5 and weigh each of them. So that when you weigh one group, and let's say it is less heavy than the other, so we have some scale, and let's say this group is heavier, well, you know that the heavier ball is in this group, right? That's logic. And you can take this group and weigh it out again. And now you can't split it evenly, so you do it in a group of 3 and a group of 2, or really a group of 2 and a group of 1. And so you would split and you would weigh these, because given you do 3 and 2, well, you always know that this will be heavier, so it doesn't really give you anything. So you split it into 3 parts like this, and you would find out maybe that these two are balanced, right? So the scales are exactly the same. So you know that this is the heavier ball. So it took you 1, 2, 3 weighings to find the ball you wanted. But what if I were to tell you that there was a better way to do this? And it's called Ternary splitting. Suppose instead of groups of 5, we did a group of 3, another group of 3, and a group of 4. And we took these two and we weighed them out, and we found that this group was heavier, that group 2 is heavier. Well, we know group 2 has the heavier ball, so we weigh out 2 of the balls, and let's say that it's again balanced. Or let's say even one of them is heavier, then we know that that's the heavier ball. If they are balanced, well, this is the ball. Now, how many trials did that take? 1, 2. One less than before. So let me explain the theory behind Ternary splitting. What Ternary splitting is all about is essentially minimizing the number of trials using some information theory, if you're familiar. So we break up the number of balls, so we're 10, into as close to 3 even piles as possible, right? Obviously, we can't do exactly 3 because we can't have 3 and 1/3 ball, because 10 divided by 3 is 3 to the 3. That goes on forever. So the best we can do is 3, 3, and 4, but that's fine, because all we need is 2 even piles to compare, right? And so in our example, let's say that these two are even. Well, we just take this and weigh out this in half. 2 even piles of 2, and we can find our heavier ball that way. Now again, that would be 3, but we're trying to find the minimum number of trials, so that doesn't matter if in one scenario it's 3 weighings. And logically, Ternary splitting makes sense if you know a little about information theory. So in with ternary splitting, we have essentially three different states, right? If we weigh these two like we did before, either the left is heavier, the right is heavier, or they're balanced. So we have three different things we can know, three different pieces of knowledge. So either we know it's here, we know it's here, or we know it's here, and we can deduce this by just one weighing. Whereas before, we only got two pieces of information, right? We either knew it was in our group of 5 balls or our other group of 5 balls. So just the left or the right. So tennessee splitting narrows down our options by a couple balls more. While just splitting it in two is called binary splitting. To get a little more in depth into information theory, we know that like the expected number of bits or information is log 2. It's fine if you don't understand this, but just understand the logic behind it. Log 2 of the number of possibilities. And bits of information really just, actually, yeah, let's just specify information. So more information is good, more knowledge is good. And so the more bits, the more information, the better. So in ternary splitting, the number of possibilities is 3. So we're splitting it into 3 groups. So we get log 2 of 3 bits of information, which, if I calculate this, is 1.583 with ternary splitting. But a little less with just splitting it into groups of 2, so binary splitting. And log 2 of 2 is obviously just 1. So we get a little more out of each weighing, a little more information out of each weighing. So ternary splitting minimizes the number of weighings by essentially maximizing how much information we get and what we can deduce with each weighing.